Welcome to Cloud on Air, live webinars from Google Cloud. We're hosting webinars daily. You're watching From Engineer to Engineer, a show where you can hear from Google Cloud customer engineers about how to solve complex problems on GCP based on real stories from the customers. My name is Yuri, and today we'll be talking about Cloud Run. Joining me today is Steren from the Google Cloud Product Management team. You can ask questions anytime on the platform, and we have Googlers on standby to answer them. Let's get started. So first, Steren, thank you so much for being here.
Thanks for having me.
Maybe we can start by you telling us what you do at Google Cloud.
That's right. I'm a product manager on the serverless team at Google Cloud.
So what does serverless mean?
How do we define serverless in Google Cloud? Well, first, it's an operational model. So at its core, it means no infrastructure management. Then we also have a fully managed security as well as a billing model, which is pay only for what you use, pay for usage.
So that sounds fantastic for the folks that are managing the infrastructure. What does that mean for developers?
Well, it also comes with a programming model. And here, instead of serverless, maybe we should say service-full, where you actually write and deploy or even consume services, microservices. It's also event-driven. You not only respond to a web request, but you also respond when an event happens. Mm-hmm. And at Google Cloud, we add to the definition of serverless openness. And so we will see what that means a bit later in this talk.
Sure. So I can already hear developers saying, that all sounds great, but what about, you supporting my specific version of a runtime? What about the language that I want to write code in? What about all these particular binaries that I want to use in my application? Or saying we don't want to be locked into one provider. What is our answer there?
Yeah, so we've heard that from developers in the past with our serverless offerings like App Engine or Cloud Functions. And so that's why with Cloud Run, we are introducing support for containers as a deployment package. So how do we define, what are containers? Why containers? How do they help with that? Well, a container can be really seen as a packaging format, a format to package software. And with a container, you can use any language that you want, any library, like language library, but also any binary, any operating system library. And, there is a very large ecosystem of base images around containers. For example, most language maintainers maintain official base images for that particular language. So to answer your question, yes, that means that you don't need to wait for the cloud provider to provide support for a specific language, because with containers, you can bring your own language within the container.
Sure, and I think we're seeing lots and lots of our customers adopt containers.
Yeah, so we have to acknowledge that today containers have become an industry standard. They are the standard for packaging software, for testing software, as well as for deploying software. Mm-hmm. So it was very natural for us to imagine a product that was combining serverless and containers.
So obviously that leads us to the next question. How do we combine serverless and containers? What is it?
We are introducing Cloud Run that brings serverless to the world of containers. So Cloud Run allows you to run any stateless container on a fully managed serverless environment.
So what do you actually get as a user of Cloud Run?
The three value propositions of Cloud Run are the following. First, it takes containers. As we discussed just before, this has a tremendous advantage of allowing you to deploy your own language, your own runtime. And they deploy fast. We will do demos later, but it's really, you don't have to think about the infrastructure. This is the second point. It's natively serverless. You just take your container and you deploy it. You only pay for when this container receives a request. This container is automatically scaled up and down. And the last pillar is the openness pillar and portability pillar. Mm-hmm. It's one experience where you want it. So we will see that in the demo that I have prepared, but you can deploy to a fully managed environment. You can deploy to your own GKE cluster, Google Kubernetes Engine, as well as anywhere Knative runs. And I will explain that a little bit later.
So, I mean, this all sounds great. I think I would love to see what it actually looks like and maybe we'll start with the developer experience.
Let's do our first demo, which is I'm going to show some code, then build that code into a container image and deploy it to Cloud Run.
Sounds great.
Okay. To start with, this is the code of my microservice. Very simple. What this microservice does is that it listens for incoming HTTP requests. So this is a Python. Then and it transforms the file that comes as a parameter into a PDF document. And this file is a Microsoft Word document. So to do that, we are using OpenOffice. OpenOffice is a open source software that allows us to transform this doc into PDF. And you see, we call it here. However, this is not a regular Python package. OpenOffice is actually something that is not present in serverless environments usually. If you use App Engine, Cloud Functions, you do not have OpenOffice available to you to help you transform that document. So
this is actually an example of having to call out to a system binary,
exactly.
not a Python library.
In that case, OpenOffice is an Ubuntu package that we installed into our container and that we can invoke using Python. But it is not a standard Python package.
All right.
This is one example why I would need a container to perform that task, because I actually need to bring a custom binary.
Okay. So how do you define the container here?
So don't be scared if you don't know containers. It's actually pretty straightforward. Let's look at this file, 16 lines long. So this file is a Docker file. This Docker file will help us define a few things. Let's take a look line by line. The very first line here is what we call the base image. Sure. As I mentioned earlier, there are a lot of official base images on the internet, and this is the official Python 3 base image, which is using Alpine Linux, which is a bit smaller than the regular one. Then we define our working directory, nothing fancy here. This is the important line, where this is the line where I decide to install a Debian package, which is OpenOffice, as well as some other packages in order to have fonts available.
Yeah, so this is the important bit, because here you're not just including Python libraries the way that you would if your container was just like executing Python code, but you're actually making a call to have that image then install another binary as part of building that container.
That's right. This part is using the Debian repository to install a custom package as part of the runtime. Okay. The next part is very straightforward. I'm installing three Python packages, and the very last line, here I'm copying my source code, and the very last line is about my start command. Sure. Like which actual Python file do I need to execute to start my application. Okay. And so the next step is to package all that into a container image. So this is only a file that describes how to build my container, but this is not a container by itself. So to do this, I have many choices. I could use Docker, the Docker command, Docker build. Sure. But Google actually offers a very nice remote build service that is called Google Cloud Build that allows me to build my container without even having to have Docker installed. Let's give it a try. So I'm in the current folder of my source code. I'm going to submit a build. I'm going to give it a tag. So a tag will be a way to reference my image later.
And I see that your tag points at GCR.io, so you're actually going to be using the Google container registry in order to store that image.
That's right. So I'm going to trigger the build, and I can discuss a little bit about this. So right now, what's happening? My source code has been packaged into a table, uploaded into Cloud Build, which is actually performing my Docker build. It has 7 steps, and it is going over these. So yes, as you said, Cloud Build will build my source into a container image, and then we'll store this image not locally, but actually in Google Cloud Container Registry. And so there I can benefit from things like vulnerability scanning. I can share images among my company and have developers actually use the same images. Because we are installing a few things in our base image, it might take some time. Let's see how long, in case I already have built this image.
Yeah, so maybe while we wait, what's going to happen once the build is done? Once that image is created and uploaded to the repository, what are you going to do from there?
So I'm going to take this tag, this container image tag, and deploy it to Cloud Run. Very simply, I can do that from the command line with gcloud run deploy. But for the sake of the demo, I decided to do it using the new user interface, the Cloud Console. So right now it's roughly finishing the build. OpenOffice has been installed. It's installing my Python dependencies, and we should have the container. Let's move to the deployment phase.
Sure.
Maybe I just want to mention that Cloud Build, of course, builds containers, but Cloud Build can also be triggered when you have a new commit in your Git repository. So that's interesting because right now I triggered the build manually, but if I were to set up a CI/CD system, this build would have been triggered automatically when there is a new change in my repository.
Okay. So far we've got our Python code that'll take an input and convert it to a PDF. And we've got it calling an open source library, and now we have our container image to run that code build.
Exactly. So that container has been designed to listen for requests, look at a document to convert, and transform it into a PDF. So from the Cloud Console, I simply navigate to Cloud Run, which is right here. On Cloud Run, I'm going to create what we call a service. So the service is the main resource of Cloud Run. And here, very simply, I'm going to select the container image that we just built. And I'm going to pick this one. It's suggesting me a service name, a location. I'm going to allow unauthenticated invocations. The reason is that I want to, for the sake of the demo, expose this service on the internet in order to show it in my browser. So that's why I'm going to allow anybody to invoke it.
Sure.
If I were to build microservices and private microservices, I might want to restrict who has access and the right to invoke my service. But let's make it public. I can give it more memory. Maybe if we have big documents to transform, I'd better pick more memory. And I'm going to allow many requests per container. Let's hit create. So what this is doing, Cloud Run is importing our container image from container registry to the Cloud Run system. It's making sure that it starts by performing a health check. The revision is now created, and it's routing traffic to it. So we get, as an output, a stable and secured HTTPS endpoint that you see here. But you see, I had nothing else to do but to create my container. There is no infrastructure to provision in advance, nothing. I just open the user interface, click create. And right now, here we have it. We have our microservice that transforms Word documents into PDFs. But I'm sure you want to see it in action.
Yeah, absolutely.
So let's give it a doc, a Word doc, and hit upload. Right now, OpenOffice is, so we download our document, OpenOffice is starting and transforming that document into a PDF that is returned to us as a response. And so what we see here is actually Chrome's PDF viewer that shows us the output of my conversion.
So that was really cool, right? We saw going from the source code and container definition in a Docker file to building the image using Cloud Build, and then through the Cloud Run UI, creating a service that actually running that container. So that's great. Now we have a container serving requests. We can access it, and we can actually use the service. What's going to happen when we have thousands or millions of people, all of whom want to convert their Word docs to PDF?
So that's the interesting part, is that here we deployed an automatically scaled container. So it's not about just one container that will process requests. It's about many container instances that will be scheduled to handle the incoming traffic or the incoming events. So let's give it a try. What I will do is I will send, with this tool, I'm going to send 1,000 documents to convert per second on my microservice. So I just started the test right now. Okay, and so we should see live the number of clients as well as the latency, the average time it takes to return the PDF back. So we see that right now there was a spike in terms of average time. It's because Cloud Run had to decide that, oh, it looks like I'm receiving a lot of requests right now. Mm-hmm. I'd better schedule many container instances in order to handle these. And so that's why we see a higher latency at the beginning because, well, starting OpenOffice takes a few seconds.
Sure.
And once this is done, once those container instances are warm, they are able to process many, many, many documents. And that is why the average latency goes down.
Sure, and now we can see that latency is down to just a few milliseconds to do that conversion once all the container instances are running.
Exactly. We can take a look at what's happening from the Cloud Run side. So, sorry, this is here. Right now, in the Cloud Run UI, I can actually see the logs that I'm of the many requests that are coming in. So these are right here in the Cloud Run Service UI. Mm-hmm. I can also take a look at a few key performance indicators in the Metrics tab. So in the Metrics tab, I should be able to see if it has updated. Not yet. Yeah. Let's give it a
so while we're waiting for the update, it looks like you can see some, just like you said, some basic metrics. So we can see kind of your golden signals, right? Mm-hmm. How many requests are coming in, like what the traffic volume is. We can see latency. We can see things like CPU and memory allocation.
That's right. Those are the things that I will care about because actually, as I will talk later, these are the things I pay for. Mm-hmm. I see the logs of my service, but maybe it's time for me to explain the concept of concurrency. Sure. Which is a very important concept when it comes to scaling instances like that. In our case, our container is able to process multiple requests at the same time. So we have a enabled concurrency that is higher than one. Yep. And this allows me to have less what we call cold starts. So a cold start happens when a request reaches a new instance, basically when we had to create a new instance to process this particular request. Sense. However, you can imagine that if I allow my containers to process multiple requests in parallel, then not every new request that comes in will hit a cold start because maybe they will be directed to an existing container. So this is why with this concurrency value, I'm actually able to scale better, like having better performances when I scale. So here we see the stacked over metrics have started to update. Of course, my request count is going up. As of course, I had no traffic, so there is. We see that the P99 of my service is 3 seconds, and the medium latency is 15 milliseconds.
Sure, and that makes sense. And the reason that the P99 is so high is because of the cold starts.
Those cold starts, yes. A few of those thousands and thousands of requests have hit a cold start. So this is what we see with that tail latency, as we name it. Mm-hmm. That's it. Yeah, all of those metrics are available in stacked over monitoring, but we provide them as an overview in that Cloud Run user interface. And as we see, it keeps going up because we are still sending traffic to our service.
Yeah. So this all looks great. I love the idea of basically going from code to container to service, really without the need to really do very much at all. But as you can imagine, I work with lots of customers that have gone down the container path. And that means they've also invested a lot in container orchestration. They've invested in GKE, they've invested in Kubernetes, and they have a whole set of skills and tooling built out around that ecosystem. What do we tell them when we say, hey, look, you can run containers in a fully managed serverless way? And they say, but what about our Kubernetes investment?
Exactly. So sometimes might make more sense, instead of running in a fully managed environment, to run in a Kubernetes Engine cluster that your company is already using. And that's why we've built Cloud Run on GKE. So let's see it in action again.
Absolutely.
I'm going to go back to the Cloud Run user interface. And here, we see the first service that we deployed earlier. And I'm going to deploy the same microservice, but this time in my Kubernetes Engine cluster. So like before, I'm selecting my container image from Google Container Registry. But this time, I'm not picking a fully managed region. I am picking a Cloud Run on GKE cluster. So this is a GKE cluster in which I have enabled the Cloud Run on GKE add-on.
Okay, so this is something that you just enable in that cluster when you create
when you
the
create
cluster.
it, or you can even enable it afterwards on an existing cluster. And here, what's interesting is that as developers, we get the exact same experience. Look, like the user interface is the same. I have the same settings that I can pick from. I can pick more memory like before, and I hit create. And like before, I have this very fast deployments, nothing to provide, no YAML file, nothing specific. And that gives us, again, a stable URL that I can use to invoke my service. And like before, I have deployed the same microservice that transformed those Word documents, except that this time, this is running on GKE in my Kubernetes Engine cluster. And all of this, let's just go back on that list view. As developer, I don't have to see the Kubernetes resources when I do that. I only focus on the code of my function, transforming it into a container image with Cloud Build, maybe even automatically by triggering Cloud Build every time there is a commit. And then I deploy it in my GKE cluster the same way I can easily deploy it in a fully managed environment. And I want to maybe show you a little bit here. You see this PDF service, this one is living in GKE. So indeed, if we open the cluster by clicking this link, then we open the Kubernetes engine and we can see under the hood what are the resources that have been created. So like if I open the workloads, I should see a few workloads that have been created by Cloud Run when I created this service, and in particular it has created a deployment, for example. So this, as a developer I have the same experience, but it goes beyond that. It's more than the same experience, it's actually the same API and container contract. So let's take a little bit a look a little bit under the hood by looking at the API. So here, when I open YAML, I see the resource definition of that particular revision. And we can see that this looks a lot like a Kubernetes API because it is. This runs on my cluster, so it's a Kubernetes resource. It's actually using the Knative API. So Knative Serving is an open source project that we launched last year that allows to run stateless, serverless workloads on Kubernetes. So what that means is that this API is something that is an open specification as well as an open reference implementation with Knative. And so Cloud Run on GKE exposes this API. Cloud Run, the fully managed version, also exposes the same API. So if I open the YAML tab on now I'm not in my GKE cluster anymore, I'm in a fully managed environment with Cloud Run, I can see the same API.
Yeah, those look exactly the same.
So that's very interesting because every tooling that you build around that API will work with the fully managed environment, will work in your GKE cluster with Cloud Run on GKE, and will even work anywhere Knative runs, which we have many partners who are also offering managed Knative solutions. This is very powerful and allows some portability between environments.
Yeah, and the developer experience that you just demonstrated absolutely supports that, right? We're able to go from source to the Docker file, building the image and deploying it on both Cloud Run and GKE. And even when you deployed the image on GKE, you didn't have to rebuild it. You literally just took the same exact image and you deployed it.
That's right, the same image, because the container contract between Cloud Run and Cloud Run on GKE is the same. So we are going to send you those events or requests on the same port in your container. We are going to only allow you to do computation when there is an actual request being processed. So to recap, we have seen two things in this demo. We have seen two flavors of Cloud Run. We have seen a fully managed version with Cloud Run. As you see, I have no cluster to manage, and as I will explain a bit later, I only pay for exactly what I use. I did not have to create a cluster, but it runs in a fully managed environment. And then with Cloud Run on GKE, I used this same serverless developer experience, but this time in my Kubernetes engine cluster. And so that allows me to, as an operator, to customize maybe the machines of that cluster. If I want to give access to my developers to graphical processing units, GPUs, well, this is something that Cloud Run on GKE will allow you to do, because you have much more control into the actual cluster, like what are the machines on which the Cloud Run services are running.
So you've said something a few times now that I found really interesting, which is this idea of pay for what you use. So can you tell us a little bit more about how does that actually work?
Yeah, so of course on GKE you are charged for the cluster and the machines of the cluster. Cloud Run automatically scales within that cluster when you are on GKE.
Yeah, but your costs there are basically bound by your infrastructure. So however many nodes there are, that's what you're paying for.
But the fully managed version of Cloud Run, there is no cluster that you are in charge of. So how are you charged? And indeed, it's a pay-per-use billing model, where you pay for the exact CPU, memory, and request and networking that your service is actually using. And this at a very, very fine granularity. We round all of those numbers to the nearest 100 milliseconds. And let's step back a bit. That means that when I'm not sending any requests or events, like right now with our PDF service, well, that means my bill is zero, literally. I am not charged for anything, and I only pay for when at least one of my container is actually processing a request. That's what we call billable time. It's when it is defined as when a container instance is processing at least one request. But as we said earlier, contrary to many function as a service products, in the Cloud Run case, one container can process many requests in parallel, which will help us with performance, but also that can be more economical. If, for example, your code is doing a lot of network calls, well, when your code is waiting for an API to return, maybe you can process other things. So that's why the concurrency setting can be very interesting when you want to optimize your cost and your latency.
Sure, that all makes sense, and I think based on what I've seen today, Cloud Run sounds fantastic. Where do you see customers using it? What use cases do you think it's really best suited for?
So we've been in alpha for many months, and now we've been in beta for a month, and we've seen basically two categories of use cases. The first one is everything that we call public microservices. So they can be something like just from a regular website, an API endpoint, a mobile backend, or maybe even just a simple webhook that you want to. A GitHub webhook where GitHub will send you a request when something has happened. All of these are actually exposing a public endpoint. But as I mentioned before, you don't need necessarily to expose a public endpoint when you use Cloud Run. There is a layer of authentication in front of Cloud Run that you can use using IAM. And so what that means is that you can do private microservices. So we've seen customers using private microservices to do data transformation, for example, transforming Word documents into PDFs. We've seen image analysis, transforming things in cloud storage into another thing. And to do that, you can have one microservice calls another one. but also you can use PubSub events, and you can push events using PubSub privately and securely to Cloud Run.
Yep. So now you've mentioned a few things, right? You talked about using Cloud Run to host websites. You talked about doing, asynchronous tasks or acting as API points and API endpoints. And I've seen other customers use Cloud Functions to do that. And obviously, both of those are products that we've had for quite some time. So now, with Cloud Run, we've expanded our serverless footprint. So can you help me understand, where does Cloud Run fit into our serverless strategy, and how customers should think about choosing to use Cloud Run versus Functions versus App Engine?
Yeah, so those three products that you mentioned, Cloud Functions, App Engine, and Cloud Run, all share the same serverless infrastructure that we have at Google Cloud. I would say they differ in terms of level of abstractions that you want to position yourself at. When you think Cloud Functions, you should think, I want to do one thing when something else happens.
Sure.
So you do one thing, and this function does only that, and you can leverage a lot Google Cloud Events, which are can trigger your function. This is the level of Cloud Functions. App Engine is really well designed for applications in popular languages. So App Engine supports many languages, and you don't have to think in terms of containers when you use App Engine. You just deploy your source code, and that gives you an HTTP endpoint. All of these are automatically scaled to handle the incoming traffic. All of these scale to 0, so when you stop using them, you're not charged. Cloud Run runs anything. So here it's not only about doing one thing or doing some things with App Engine in some languages. Cloud Run is really allowing you to run any workload that can be invoked in some way on a fully managed serverless environment. And containers are just the way to package your code into a standard packaging format and then deploy it to our serverless environment.
Yeah. So maybe one way by which customers may end up making that decision is determining whether or not they're comfortable, operating containers, right? Because in order to use Cloud Run, not necessarily operating containers, but building containers, right? Because in order to use Cloud Run, they still have to do things like define the containers. They have to, have some way to build them, even if it is as easy as using Google Cloud Builds. So
that's right. I really want to emphasize, as you've seen during the demo, building our container was just a matter of writing a small file and then using the gcloud build command and then using the gcloud run deploy command. It's really straightforward.
All right, awesome. Well, hey, Steren, thank you so much for being here today to walk us through Cloud Run. I really appreciate it. And thank you for tuning in. Please visit Cloud OnAir for more content from Google Cloud experts.